Hi everyone, and we're going to look at going through a walk and talk maths mock paper, and this is just a paper from Edexcel GCSE Foundation. Okay, so we're just going to look through each of the questions, and I'm going to go through them in turn, as if I was completing this paper in our mock exam. So the first thing we're going to look at, question one, okay, is we've got write 3/10 as a percentage. So from a working perspective, it's if you can think the bottom number is easy to get to 100. Okay, remember the percentage is out of 100, so I could put the fraction as over 100. Okay, and then to get 10 to go to 100, I've got to do a multiplication factor of 10, times it by 10. So if I can times the top number by 10 as well, doing the same thing to the numerator and denominator, so I end up with 30 out of 100. So I'm going to end up with 30%. Okay. Sometimes it's not as easy to get the denominator to get to 100. So if you can get the denominator to go to 10 and then get to 100, that's what my advice would be on this question. Okay, so question 2. Okay. Write the following numbers in order of size, start with the smallest number. So if you can think of this one like a temperature probe. Okay, we've got 0 there, negative numbers down there, positive numbers up there. Okay, so we're looking at which is the smallest negative number. So again, if you think 0, the biggest number away from, so we've got -10 down here. I've got -7 next. I've got -2. I then hit my 0. I then hit 1, and then I've got my last number being 8. So in order of size, starting with the smallest, it will be -10, -7, -2, 0, 1, and 8. So again, just get in your head, anything when it's talking about negative numbers, think about temperature, and you won't go far wrong. Okay, so question 3. Okay, write 9/100ths as a decimal. So with this one, you're going to do exactly what it says on the tin. 9. Remember that the fraction line means divide. Divide by 100. Now it's very easy in these cases to get these the wrong way around into your bust up. So we've got 9 divide by 100. So the 100 is going to go outside now. Okay. So 100 into 9 doesn't go. So 0. Remember there's a decimal point after the 9. So 9 is going to go backwards. Put a 0 there. 100 into 90 still doesn't go. 90 goes backwards. 100 into 900, it goes 9 times. So my answer is 0.09. Okay, what you could do in relation to this is if you wanted to think about it as 9, if I divide by 100, okay, I'm dividing, so my decimal point, okay, will go this way. So if I divide, I'm going to make the number smaller. If I times, I'm going to make the number bigger. So I'm dividing by 100, so I've got 2 zeros, so I'm going to move it 2 spaces. Decimal point's going to go there, and I could infill with placeholders. So again, 0.09. Okay, so that's just a different way of thinking about it as opposed to doing the bust up division. Okay, let's go to the next question. Write 327 correct to the nearest 10. So if we think we've got units, tens, hundreds, so we're rounding to this point here. So we've got 3, 2, 7, and we're rounding the digit number 7. Remember, anything 5 or above is going to round up. So we're going to round this digit here up by 1. That's going to give me a 3. So my answer would be 33. Thinking about this though, I've got 327. If I round it, it's not actually going to be 33. It's too far away. So I need to make sure, because this isn't a decimal number, that I put my placeholder in there. So it's going to be 330. And again, thinking about it, what we're looking to say is it closer to 330 or is it closer to 320? And we can see it's closer to 330. Okay, question 5. Okay, write down the value of 7 squared. 7 squared can also be written as 7 times 7. 7 times 7. Straightforward one. Gives me 49. Okay. Question 6. Write down the mathematical name of this quadrilateral. Okay. Well, we can see it's got one pair of parallel sides. And we can see it's got a sloping side on each side. Okay, we're not told anything about the length of those sides, that they're the same or they're not the same. But any time like that, we're used to seeing this shape written that way up, and it's a trapezium. Okay. If it wanted to be a quadrilateral, very quickly on this one, okay, if we've got that shape, these sides are not parallel. Okay, so the name quadrilateral would relate solely to that particular shape. Okay, if the sides are parallel, it's either going to be a trapezium, or it could be, if I've got two sets of parallel sides, it could be a parallelogram. They're the two ones to look out for. Okay, but this one is a trapezium. Right, on we go. Question B. Write down the name of this mathematical 3D shape. Circle on the top. Okay, so it's going to be a cylinder. Only 3D shape really that we come across for GCSE. So a cylinder on that one. Question 7. £42 is shared equally between 3 friends. How much does each friend get? So we're thinking about this and we're thinking about this. So straightforward, I've only got 2 pieces of information. So we could say, if I'm going to split them equally, £1 to each, I could just split that down really, really quickly by saying 42 divided by 3, put it into 3 equal parts. So here's my £42. If I cut it equally into 3 pieces, how much is going to go into each block? So 3 goes into 4 once, remainder 1. 3 goes into 12 4 times, so that's going to give me £14 in each block. And if I wanted to check that and add them together, 10, 20, 30, 34, 38, 42. So each person would get £14. Question 8. Grace recorded the eye colour of each of the students in her class. The frequency table below shows her results. So they give me this information, so I'm going to need to do something with this information in relation to this graph. So I'm just going to zoom out for this one. Okay. So Grace then drew the bar chart below for this information. Okay. The frequency up the side goes up in 2s. I've got the 3 eye colours on, blue, brown and green. Okay. So if we can just go down to the question. Write down one thing that is wrong with this bar chart. Okay, so let's check the colours for a start. We've got blue, and that's at 10. We've got brown, and that's at 15. Hang on, that's at 16. So there's that one thing. Okay, it should be there if that was the case. So we could say brown should be 15, and it is marked as 16 on the graph. Okay, it only wants one thing. I found my one thing. I'm just going to check green. Green is 4. Okay. Another common thing, depends on which type of question you have. Make sure that the gaps in between your bars are the same width, and the gap width of my bars is the same width. That's another common mistake that they do. It doesn't matter that the first bar here is a different width. It's the gaps in between the bars that's the most important one. Okay. We've got eye color listed down. We've got the titles listed down on the graph as well. And the other thing that they tend to do is sometimes they will do a mistake on the axis. So have a look to make sure, if you can't see if they've plotted them all at the right level, see if the frequency goes up like 2, 4, 6, 10, 12, so that this bit here, it's jumped and it's gone up in 4s, not 2s. That's another thing they could potentially do. Okay. Next question. Question 9. Danny buys 1 loaf of bread for £1.20, 1 bottle of milk for 70p, 2 packets of cheese for £2.30 each packet. Important one there. Okay. Danny pays with a £10 note. He says I should get £3.30 change. Is Danny correct? And at this bit, you must show how you get your answer. So if you've got a question like this and it says you must show, if you just put the answer, you'll get no marks. You won't even get a mark for the answer if you get it right, because you must show how you've got your workings. Okay, so let's see where we go. So I've got 1 loaf of bread, £1.20. I've got 1 bottle of milk, 70p. I've got 2 packets of crisps for £2.30 each. Now I could just times that by 2, so I'm not adding 2 lots of it. So 2 times 0 is 0, 2 times 3 is 6, 2 times 2 is 4. Okay, so £4.60 is what I'm going to add on my column here. And that's, I'm just going to add those up. Okay, so we should have 0, 6 and 7 is 13, 14, 15, 4, 5, 6, £6.50 is what it's going to cost me. If I pay with a £10 note, I've now got to do the subtraction, £10, take away £6.50. So 0 from 0 is 0. I can't take the 5 from there, so I'm going to have to borrow 1 from that to give me £9. And then 5 from 10 is going to give me 5. 6 from 9 gives me 3. So I should have £3.50 change. Okay. Is Danny correct? Make sure we do this bit. Is he correct? No. And all my workings are there. So we would need to see that we've either multiplied this part here, the 230 times 2, that's the first mistake they want you to make. Okay, we've added and we've got a complete sum there of £6.50. Okay, we need to say, if we could, even if we did this last bit in our heads and said, well, I'd get £3.50 change, ideally we need to see the £3.50 and no. So think 1 mark, 2 marks, 3 marks for the £3.50 and the no. You have to have both those. If you don't have no, if you've not answered the question, it asks in the question, is Danny correct? So yes or no answer on that one. But if you don't show any of the workings, even if you've done it all in your head, you'll get 0 marks. Okay, question 10. Rachel records the temperature in her garden at noon each day. On Monday, the temperature was 5 centigrade. On Tuesday, it was 10 degrees less than the temperature on Monday. On Wednesday, the temperature was 3 degrees greater than the temperature on Tuesday. Find the difference between the temperature on Monday and the temperature on Wednesday. You must show all your workings. Again, I've got to show how I've done it. Now, there's a lot of words in that, and there's a lot of different steps that we could look at. So do a line at a time. Don't look at the whole question and try and do it all in your head at once. So again, we're thinking a temperature probe. So here's my temperature probe. All this is a, if you like, a number line where I've shown it like a temperature probe. So remember, the temperature probes have the little ball on the bottom of them. Okay, so on Monday it was 5 degrees. And I'm just going to place them on my temperature probe, or on my number line. On Tuesday, the temperature was 10 degrees less than the temperature on Monday. So if Monday was 5, I'm doing 5 degrees, take away another 10 degrees. So if I take 5 away, I get to 0. So I've got to take another 5 away. So I'm down here at minus 5 degrees C. So we've now done the second line. The third line. On Wednesday, the temperature was 3 degrees greater than it was on Tuesday. So remember, this is Tuesday. This is Monday. So where was it on Wednesday? I've got to go back up 3 steps. So from there, I'm going to go minus 4, minus 3, minus 2. So that point there, minus 2 degrees. and that's Wednesday. Okay, now go back to the question. We've done that line as well. The question states, find the difference between the temperature on Monday, this one, and the temperature on Wednesday, this one. Okay, so I want to know how many steps we're going to have to do to go from Monday to Wednesday. Well, I do 5 steps to go to 0, and then I've got to do another 2 steps. Okay, remember differences subtract. If I wanted to show it mathematically, I'm doing that. Okay, so 5 minus minus 2, to find the difference it's minus, and that number there is minus 2. Okay, so 2 negatives make a positive. So as you've probably seen, I'm looking 7 degrees. The units are there. I don't need to write the units. They're there for me. Okay. Note the most common mistake that people want you to do here is going, oh, I've got to take them away. So that take away 2, that means it's 3 degrees. Okay, that is wrong. Okay, remember I've got to do 4, 3, 2, 1, 0, minus 1, minus 2. So I've gone down 7 steps. So whether you draw it and you physically see how far you've gone up and down, you could do that on the paper, or you could show it mathematically this side, whichever works for you. Okay, question 11. The pictogram shows information about the number of video games sold in a shop on Monday, on Tuesday, and on Wednesday. So the first thing we're looking at is this key over here. It's really important. So we can see that these 4 dots, these 4 squares represent 8 video games. So my first thing is to say, well, hang on then, one of these little squares then must equal 2 video games. Okay, once I've got that, I could say, well, that's 8, that's 8, this one's 8, this one's 8, 2, 4, 6, that one's 6, that's 8, that's 2. And remember, we're adding all of these together to find out how many there are. So I can say Monday there were 16, 8, 16, plus 6 gives me 22, 8 and 2 gives me 10. Okay. Now, without even looking at the question, we didn't look down as far as that question, but we've just answered the question for 8 anyway. How many games were on Monday? 8 plus 8 gives me 16. Okay. More video games were sold on Tuesday than on Wednesday. How many more? Again, we're looking for the difference. If we're looking for the difference, we're subtracting it. So on Tuesday, there was 22. And on Wednesday, there was 10. The difference between that is 12 games. Okay, on Thursday, on Thursday and Friday, a total of 32 video games were sold in the shop. 1/4 of these video games were sold in the shop on Thursday, and it's asking me to complete the pictogram for Thursday and Friday. So 2 pieces of information. Again, do it line by line. So the first one is there were 32 games. So if there's 32 games, I'm going to divide it into 1/4. So I'm dividing it into 4 pieces. Here's my 32. If I half it, that will be 16. If I half it again, I'm dividing it by 4. 4 goes into 3 0 times. 4 goes into 32 8 times. So 8, 16, 24, 32. So 1/4, this one here, was sold on Thursday. So I can draw a box. Make sure it's the same size as what the box is there. Okay, be careful. Take a little bit of time and make sure when you're drawing it, okay, that your shape really is as much as you can the same shape as the one above. So 8 on that one, and we know we now need 3 big boxes. So 1, 2, 3, and we can cut them into 4s. So again, we've got 8, and we've got 24 on that one. Add them together gets me 32. All right, and that's that question. Question 12. There are 2 drama groups in a school. Okay, again, we can see we've got quite a wordy question. So let's do it a line at a time. There are 2 drama groups in school. So drama group 1, drama group 2. In one group, there are 36 boys and 48 girls. So let's, as soon as we start getting a split like this, let's turn it into a ratio. So we've got 36 boys and we've got 48 girls. In the other group, 3/7 of the students are boys. Okay, so this side, boys, there are 3/7 that are boys. Okay, the rest of the students are girls. Well, again, think about it. If we've got a big box here and we cut them into 7 parts, 1, 2, 3, 4, 5, 6, 7, and 3 of them are boys, I've got 4/7 left. So 4/7 must be girls. That's got you 1 mark, just to literally put that there was 4/7 there. Okay, and says the ratio of the number of boys to girls is the same for both groups. You must show how you get the answer. So, is and correct? Right, the ratio of boys to girls is the same for both groups. Well, think about the relationship between these numbers. Okay, we've got 36 boys and we've got 3 out of 7. So we're looking for a link between those two. Okay, and if we said, if I did 3 times 12, that would give me 36. So we're looking to say, okay, if I did the same thing to the girls, is it the same? Okay, so 4 times 12 also gives me 48. So that proves my point that they are the same ratio. Okay. You could times the bottoms out as well if you wanted to, and put these into a fraction. Okay, I'm not going to confuse things by doing that. That's the only piece of working you'll need to do. Look to see that the number of boys, how can we make it the numerator on that fraction? Okay, and the same with the girls, and that will confirm whether it works or not. Okay. Question 13. A number sequence starts 1, 2, 4. Emma says the next term is 7. Explain why Emma may be correct. So she may be correct. It doesn't mean that she is. Okay. So we've got to try and prove why she may be correct. So let's do that. Let's go 1 to 2 to 4 to 7. So we need to try and prove what's happening with each of those. So let's just look at the terms. This one, I'm adding 1. This one, I'm adding 2. This one, I'm adding 3. And that would get you the mark. Okay, that's mathematically telling the examiner that you're adding 1 more each time. Adding 1 more each time. So that may be the reason for the sequence. That may be the rule to term rule for that sequence. Now, let's go on to part B. Here are the first 4 terms of a sequence of triangle numbers. 1, 3, 6, 10. Now, there are lots of different ways that you could approach this question. Okay, so the sequence of triangle numbers. Well, if it was me on this question, what I would do is I'd try and draw them. So here's my first one. There's 3. Add another 3. There's 6. Add 4 this time. There's 10. That's the 4th term, remember. First term, 2nd term, 3rd term, 4th term. We want the 8th term. So it wouldn't take me a lot to carry on the sequence. So the 5th term, I'm adding a row of 5. The 6th term, I'm adding a row of 6. The 7th term, I'm adding a row of 7. And the 8th term, I'm adding a row of 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to sum those numbers together. 1 dot plus 2 dots plus 3 dots plus 4 dots and so on. So I've got 1, 3, 6, 10. That's my sequence. Add 5 gives me 15. Add 6 gives me 21. Add 7 gives me 28. Add 8 gives me 36. So my answer would be 36. Okay. Question 14. 3 kilograms of carrots cost £1.80. 2 kilograms of carrots and 5 kilograms of potatoes cost £3.45. Work out the total cost of 4 kilograms of carrots and 2 kilograms of potatoes. You must show your workings. Right. So 3 lots of carrots equals 180. Let's start with that one. So if 3 lots of that equals 180, if I divide through by 3, I can find out what 1 lot of carrots equals. And that's going to give me 60p. So carrots equals 60p. This one, do it in a different colour so we can follow it through. I've got 2 lots of carrots plus 5 lots of potatoes equals £3.45. Well, I know the carrots cost 60p. So if I do 2 lots of 60p, that gives me £1.20. And I've got 5 lots of potatoes, still equaling £3.45. To get rid of the £1.20, remember I need to finish off down here with p equaling just a number. So we're going to take our £1.20, okay, and we're going to do the opposite, the inverse function. So it's plus 120. I want to make it 0 because I want it to disappear from this side of the equation. So take away the same value, take away £1.20 the same side. Remember, this is like a set of scales. Whatever we do on one side, if we do something here, we have to do the same thing this side as well, otherwise it won't balance. So taking £1.20 off each side, that's going to make 0, and it's just going to leave me 5 lots of potatoes, and we'll know how much they cost. £3.45, take away £1.20. If I take £1 away, that gives me £2.45. And if I take 20p away, that gives me £2.25. And my final step, divide through by the coefficient, the number in front of p. Whatever that number is when you get to this stage, if that's a fraction or a decimal or a negative, whatever it is, divide by exactly the same number. So this one we're dividing by 5. Divide this side by 5 as well. So looking at this one, 5 into 2 doesn't go. That's the system. 5 into 22 goes 4 times with 2 left over. 5 into 25 goes 5 times. Okay, so that gives me 45 pence. Okay, so make sure this sort of working you're doing, don't be doing everything in your head. Always try and work it through. We know the value of the carrots is 60p. The value of the potatoes we now know is 45p. Okay, so 45p for the potatoes. Then we're going to do the last bit, which is work out how much. 4 kilograms of carrots. Okay, so 4 carrots plus 2 kilograms of potatoes. 2 potatoes equals. Okay, so we've got 4 lots of 45p, and we've got 2 lots of 60p. So 45p times 2 gives me 90, times 4 gives me 180. So I've got £1.80, 180 pence, or £1.80 for the potatoes. 2 times 60 gives me £1.20, or 120 pence. And if I add that together, that's going to give me £3. Now there's quite a bit of work that goes into that question. It's a 4-mark question, and you can see everything that we've got there to be able to get us to the end goal of £3. Okay, don't be afraid to show all of your workings, but don't write in this part here anywhere around the outside. If you write in there, it won't be marked. Okay, so let's go down to the next question. Okay. Expand means multiply. Okay, so I've got a 2 on the outside, I've got an A and a D on the inside. So I'm going to have to times the 2 by the A, and then I'm also going to have to times the 2 by the other term in that bracket, the D. Okay. So 2 times A gives me 2 lots of A. I'm just doubling it. 2 lots of D gives me 2 lots of D. Okay, and that's my answer. I can't put A's and D's in the same pot. They're different things, so I can't combine them. Okay, I can only combine them if I'm multiplying. And that's multiplying between the terms, this part here. So if it was 2A times 2D, I could combine them then, but I can't if they're 2 different terms. So I've got A plus D, so I have to leave them as 2 separate terms. Factorize is the opposite of expand. So this had a set of brackets in it. Okay, factorize means I'm going to take something out that is a common factor of both numbers. So we've got 6y squared minus 5y. So my first protocol, let's look at the numbers. Is there any number that goes into 6 and 5 that's the same factor? And other than 1, no, there's not. Okay, 5 is a prime number, so it's only divisible by 1 and 5. They're the only pair of factors it has. Okay, so if I took a 1 out, it's not going to make any difference at all. I could take the 1 outside, but it's still 6y squared minus 5y. It's not altering it at all. Okay, so what else could I take out? Well, we've got a y here, and we've got a y here. Okay, I've got y squared, that's y times y, and I've got 1y on its own. So I could take one lot of y out. I've got one lot of y here. So let's take the y out. Let's put a bracket. Now if I take that one y out, and I take one of these, remember it's y times y, take one of those y's away, that's like removing the square. So I've just got one y left. So what have I got left on this side? I've got 6y on the first term, minus, and I've just got my 5 left there. So we're trying to take out something that's the same, so I would end up with these 2 variables inside my bracket. And remember, I've taken this y outside of the bracket. Okay, I'm only taking one thing because it's common, it's a factor. So when I multiply that back out, y times 6y would give me 6y squared, and y times negative 5 would give me negative 5y. So I'm back to where I started. Question C, solve. So I need to find the value of x. What does x equal? So first off, let's try and make it easier by getting rid of this 7. Let's just zoom in so it makes it a little bit clearer. Okay. So because that's a negative, we're going to do the inverse, the opposite function to both sides. We're going to add 7. 7, take away 7, makes nothing, so it's simplified it to 4x. 37 add 7, okay, is going to give me 44. Because it's a non-calculator paper as well, notice how it's very easy. You could say, oh, I'll move that across there and I'm just going to take away 7. Okay, we're doing the opposite function. It's the inverse function. Or the opposite. If it tells me it's times, I'm going to divide it. If it tells me it's take away, I'm going to add it, and so on. So, like we did before, we're going to divide through by the coefficient, the number in front of x. So 4 divided by 4 gives me 1 lot of x. 44 divided by 4 gives me 11. So x equals 11. Okay. And again, thinking about numbers, your marks, there's a 2 mark for this one. 1 mark for that step. 1 mark for that step and the answer. So if you do one of these steps correctly, you'll get half marks. If you do both, you'll get the right answer. Okay, so now we start getting on to the more the slightly harder questions. They start throwing algebra in it, and you've got to make assumptions based on what you know. So first thing it says, this shape is a kite. Okay, so what do we know about a kite? Well, to be a kite, this side has to equal this side, and this side has to equal this side. So if I know that, Okay, it's going to help me a little bit later on. Now, let's look at the first question. AB, so this line here, okay, it's saying is 4x minus 2 centimeters long. We don't know what x equals. Okay, so let's look at what Jasper says. Jasper says that x could be 0.5. So all it wants me to do is put my function down here. And where the x is, I'm going to substitute in 0.5. Remember, that's 4 times x. So I'm going to do 4 lots of 0.5. So 0.5 times 4 gives me 20. So 2.0 because I've got 1 decimal place. So that's going to be 2. Well, if that equaled 2, 2 take away 2 is going to equal 0. And if it equaled 0, it wouldn't exist. It's not going to be there because 0 we wouldn't write it, it wouldn't show at all. Okay, so if it was 0, it wouldn't exist. And that's the correct answer for that question. Okay, you just need to justify that if that was 0.5, my answer would equal 0. Okay. Next question. Okay, AD equals 3AB. Okay, and the kite has a perimeter of 64 centimeters. Again, I'm going to just zoom out for this one so we can see it all on the screen at the same time. Okay, so we know that this bit here, A to D, this bit, okay, equals 3 lots of AB. So this measurement is AB. So if AB equals 4x minus 2, what does 3 lots of it equal? Okay. Now, be careful with this one. If we wrote it like this, okay, you might be tempted to just multiply the 3 by the 2. Remember, that is in brackets. So I'm just going to go down a little bit more, and I'm going to write the whole thing in brackets so it looks a little bit clearer. Okay, so we've got 4x minus 2. Remember, that was in brackets. If I put my 3 at the front of my bracket, that's similar to the expand question we had a little while ago. So all we're going to do is do exactly the same thing, and we're going to multiply it out. 3 times the 4 gives me 12. 3 times the 2 gives me 6. Remember, I've got a positive and a negative, so my answer will be 3 times negative 2 is going to give me negative 6. So it wants me to find the value of x. So I've got 3 times 4, bring that x with it, so 12x minus 6. 12x minus 6. Remember, they're telling me that the perimeter equals 64. So we need to know what the perimeter is going to equal. Okay. So this is where we start getting, I'm just going to go down to the marks on this one. We've got 3 marks for this place. Remember, my factorization, we're probably only looking 2 marks top, so there's got to be something else I need to do. So here's my kite. We now know the top one was 4x minus 2. We know that these two are the same. So that one is 4x minus 2. We know that this one and this one are 3 times as big. We just calculated that bit there. So this is 12x minus 6. And this must be 12x minus 6. And to do the perimeter, remember what we're doing is we're adding all the way around. So we do that one, add that one, add that one, add that one. So let's do that. 12x minus 6 plus 12x minus 6 plus 4x minus 2 plus 4x minus 2. Okay. Think about how we did the, we've done before, collecting like terms. So we've got 12 plus 12 gives me 24, plus 4 gives me 28, plus 4 gives me 32 lots of X, put in a bowl. And then I've got minus 6, that's minus 12. Take away another 6, minus 14. Take away another 6, minus 16, equals 64 centimeters. Okay, so now we're at the point we can use that measurement. Okay, we can't use it before we get to that point. So now we're going to find the value for X. So we're trying to make life easy. Let's get rid of this one by doing the inverse. Add the 16 to both sides. Add 16 to there. That one disappears. So 32x equals 80. And then I'm going to divide 80 by 32. It's at this point that you might think, don't know what 32 times table is. So if you don't, we just write it down. If you add 2 to both to the right hand side each time, 32, 4, 6, 8, 10. And this side you add 3 to. 3 plus 3 is 6. Plus 3 is 9. Plus 3 is 12. Plus 3, add 1. Plus 3 gives me 15. Add 1 gives me 16. So 32 into 8 doesn't go. 32 into 80 goes 1, 2, doesn't go 3 times, so it goes twice. How many left over between 64 and 80? I've got 16 left over. There's my placeholder. 32 and 160 goes 5 times. 2.5. Okay. One thing you could try, and just going to go down a little bit on this one, okay, is if you didn't know, if you wasn't very good at doing division in relation to larger numbers like that, you could try and simplify these numbers. Okay, so they're both even, so I could half them down. So half of 32 is 16, half of 80 is 40. That's exactly the same answer, same sum, because we've done the same thing to both sides. They're both even, so let's half it again. So how many 8s would go into 20? It's still even, so let's do the same thing again. How many 4s go into 10? Let's do it again. How many 2s go into 5? That's a lot easier. 2s into 5 goes 2, with 1 left over. 2s into 10 goes 5. So again, think about making life a little bit easier and simplifying if it helps. Okay, that's not part of this question, but it's just a mental method that may help. Just halving down each side if they're even numbers. Brilliant. Right, question 17. So halfway through the paper, just over. So Heidi wants to make some biscuits using this recipe. So we're aware that it makes 12 biscuits. Okay, 125 grams of butter, flour and sugar, 250 respectively. Heidi thinks she has 500 grams of butter, 700 grams of flour, 250 grams of sugar. Assuming that these weights are correct, so let's say that they're right, work out the greatest number of biscuits Heidi can make. You must show all your workings. So again, we don't show the workings, we don't get any marks. So your first approach is, how can I lay this out so the examiner knows what I'm talking about? Okay, so to make 12 biscuits, you have butter, flour, sugar in that ratio. Again, we're listing 2 or 3 things together in the same thing. Let's use a ratio. We've got 125 grams, 200 grams, 50 grams. Okay. Let's make 2 batches. Let's make 24. So we're going to double it. That's going to give me 250. That's going to give me 400. That's going to give me 100. Okay, so we can still do that. Think what the values we've got. We've still got enough. Let's add another lot of 12 on it. So we're going to add these two together now. So we're going to do 5, 7, 375. 200 plus 400 gives me 600. 50 plus that gives me 150. We've still got enough. Let's do one more lot. Okay. So let's add another 125 to this. So add 2 5s, so that gives me 10. Carry 1, 9 plus 1 gives me 10. 4 plus 1 gives me 500. Right, that's the limit of butter. Adding another 200 gives me 800. Okay, can't do that one. Okay, and let's do this one, 250. Add another 50, that gives me 200. I've still got plenty sugar. Okay. So 12, 24, 36. Okay, that was the third one. Okay. And then I've got another batch that would be 48. So I can't make 48. Can't make that one because I've not got enough flour. I could make this one and think my limiting factor is the flour. So for each 12 cookies, okay, I can make, it's going to cost me 200 grams of flour. Okay, for 12 biscuits, it's going to cost me 200 grams of flour. Now I've got 700 grams of flour here. So I've got halfway between these two. So if I went the halfway point between 36 and 48, remember each batch is 12 biscuits. Half of 12 is 6. So I want the halfway point. So that's going to give me 42 biscuits. It's the maximum I can make. Okay. To do 42 biscuits, if we want to check it, okay, I'm going to put 42 down there. Again, if we want to check that. Okay, so let's go back to the top of our sum here if we wanted to check and say 12 biscuits equals 200 grams of flour. 6 biscuits is half of that. So let's half this. He's going to give me 100 grams of flour. Okay. I've got 700 grams of flour. Okay. So I can make, for every 6 biscuits, 7 times 6, which gives me my 42 biscuits. Right. Second part. Heidi is wrong. So totally different to the question above. Right. The only difference is she's wrong. She has more than 250 grams of sugar. Does this affect the greatest number of biscuits Heidi can make? Give a reason for your answer. Well, we've realised that the limited factor, so the limiting factor was flour. So it would have no effect. Okay. Purely because this bit here is our limiting factor. Okay, question 18. Again, let's zoom out for this one. On the grid below, draw the graph of y equals 2x minus 2 for values of x from minus 2 to 3. Now, when they give me this, they're giving me the x value, okay, of minus 2 to 3. So the first thing I'm going to try and do, if there's not one already, is I'm going to draw a y-x table. Okay, we know the values go from minus 2, minus 1, 0, 1, 2, 3. So we are plotting where the x coordinates are. That's what the x values mean. We need to find out what y equals when x equals these values. So here's my equation, 2x minus 2. Now, my advice is always start at 0 because that's your easiest one to do. Okay, because when x equals 0, 2 times 0 is 0. Take away 2 just gives you minus 2. So that's your y-intercept So when x equals 0, y equals -2. So we can plot that point. The next one, always go up to the positive so we can see a pattern then. So what about when x equals 1? Well, 2 times 1 is 2. Take away 2 gives me 0. Okay, so we can work this out. Oops, equals -2 equals 0. Okay, so when x equals 1, y equals 0 on our equation. The next one, 2. What about when x equals 2? So I'm just taking this value and substituting it in. 2 times 2 is 4. Take away 2 gives me 2. So when x equals 2, y equals 2. And the last one on this side, what about when x equals 3? 2 times 3 is 6. Take away 2 gives me 4. 3, 4. Okay. Now I don't even need to worry about trying to measure calculate what the negative side is now, because I can see the pattern. It's a linear graph, and I can now just plot it in relation to what I've already got. Okay, so we can see here 4, 2, 0, -2. We're going down by 2 each time to go backwards. So it's going to be -1, -4, and -2, -6. And that would be my values. Yeah, just trying to get this on here. And then what you would have to do is it's slightly difficult on this particular system, but try and draw a straight line through those points. Oops, make sure it's a straight line and you use a ruler. Okay, difficult to do on the screen. And then you've plotted the points and you've drawn the line. If you do not draw the line between the points, you lose a mark. Okay, so we've calculated the points at the top here. We've plotted the points on -2, -6, -1, -4, 0, -2, +1, 0, 2, 2, 3, 4. Okay, and imagine these points at the top here. So 3, 4, that's your top point. 2, 2, 1, 0. So we've got our list of coordinates along the corridor, up the stairs. Okay, and then -2, -6. And these are the points that we plotted. Okay, and that's how you plot that straight line graph. And again, just coming out a sec. And that is the full question. Okay. Question 19. Robin buys a watch for £80. He sells the watch for £56. Work out his percentage loss. Okay, if you can do this one, brilliant. Okay. If you can't and you always struggle on percentage loss questions or the percentage change questions, try and picture it logically how you would work this out. So he buys it at £80, which is 100% of the cost. Okay. He sells it at £56, but we don't know what that percentage is. Okay, that's what we've got to find. So if we said if 100% is 80, what's 10%? And 10% would be £8. Okay. So let's think about this. 56, 8. So 8 times what would equal 56? 8 times 7 would equal 56. So remember, 10% is £8. So if that's 10%, 10 times 7 will give me 70%. Okay. So that's a way to try and picture it to find out what the percentage is. Mathematically, what you're doing is you're saying, what's the difference? Divide by the original. and then times it by 100. Okay. So the difference, 80 take away 56, the difference is 14. 24, sorry. 24. Okay. So if the difference is 24, 24 divide by 80. And again, I'm going to try and simplify this. If I divide this by 10, it makes 8. Divide this by 10, makes 2.4. So I've just simplified that by dividing both the inside number and the outside number by 10. Because I don't want to do the 80 times table, I just want to do the 8. 8 into 2 goes 0. Okay, carry it backwards. 8 times 24, 8 into 24 goes 3. Okay. And 30% is my percentage loss. Okay. I've dropped from 80% to 70%. My percentage loss is 30. If I times this by 100, 1, 2, that gives me 30%. Okay, so the difference divided by the original times by 100 gives me a 30% loss. It was worth 100%. It's now worth 70%. It's dropped by 30%. So two different ways of doing that. Mathematically is in the red, logically is in the purple. Okay, question 20A. Work out 3.67 times 4.2. Again, this one is just manual multiplication. So I'm just going to do 3.67 times 4.2. Now, the only thing I'm going to do here is I'm just going to highlight that value, and that value. So I've got 3 digits that are behind the decimal place. Okay, now when I come to multiplying it, I'm going to come back to that 3 decimal places. Okay, and I'm just going to times it out as if I would do a normal column multiplication sum. So 367 times 42. 2 times 7 gives me 14. 2 times 6 is 12. Add 1 gives me 13. 2 times 3 is 6. Add 1 gives me 7. 0 for my placeholder because I'm timesing by the tens column. 4 times 7 gives me 28. Carry the 2. 4 times 6 is 24. Add the 2 is 26. Still carrying the 2. 4 times 3 is 12. Add the 2 gives me 14. So I've got 4. 3 and 8 gives me 11. 13 and 1 gives me 14. 4 and 1 gives me 5. And 1 gives me that. Now remember, I've got 3 decimal places. 1, 2, 3 digits. So I've got 1, 2, 3 digits. Put my decimal point there because I've got to have 3 numbers behind my decimal place. So my answer for this one would be 15.414. Okay, next question. 59.84 divide by 1.6. Now again, we're going to try and make this easier by simplifying the sum before we do it. I don't want to do the 1.6 times table. I don't want to confuse things by having decimals in there. So if I can times this side by 10 and times the inside by 10, I'm getting rid of that decimal place. So that would end up with 16 into 598.4. So I'm just moving it one place. Now again, we've got, this is simplifiable. So they're both even. So I could simplify it again. Okay. Or I could do the 16 times table. Let's do the 16 times table. Let's do it that way. 32, 48. And if you struggle doing this, I will show a different method in a second. So 80, 96. Now remember, we had to do the 16 times table before, earlier on. So if we've already written that once in our work, we could just write it again. And we don't need to write it again. We could just go back to that particular page. Okay, so we've got 96, 106, 112, 128, 134, 144. Okay, and then we've got 160. I'm not going to need to do any more than that. 16 into 5 doesn't go. Carry it backwards. 16 into 59 goes 3 times. Remainder 11. 16 into 118 goes 1, 2, 3, 4, 5, 6, 7 times. 6 left over. And 16 into 64 4 times. Remember my decimal point where it sits in myself. So 37.4. Okay. Now, I did say I would show a different way for that one. Again, if you don't like doing anything that borders on long division in relation to bigger numbers that leads you in that way, you could say if I've got 16 and 598.4. Okay, if I look to half of that number, that's going to give me 8. And providing it ends in an even number, we can always half it. Okay, so half of 5 is 2.5. So I'm going to put my 2. I'm going to keep my 5 up there to think about what I'm going to do with that in a minute. Okay, half of 9 is 4.5. Okay, but remember this 5 is still got to be included. So 4.5 plus 5 gives me 9.5. So 9. Bring the 5 backwards. 8 into half of 8 is 4. Add to that gives me 9. And then half of 4 gives me 2. So 598.4, if I half it, gives me 299.2. All I've done is just that divided by 2. 2's into that goes 2, remainder 1. 2's into that goes 9, remainder 1. 2's into that is 9. 2's into that is 2. So all I've done is divided it by 2. Really easy to do, to divide it by 2. Okay, I've still got an even number and an even number, so I could do the same thing again. Let's do it again. 299.2 divided by 2. 2's into 2 goes 1. 2's into 9 goes 4, remainder 1. 2's into 19 goes 9, remainder 1. 2's into 12 goes 6. Okay, so I've halved it from there to there. I've halved it again, so 4 would go into 149.6. Okay, if I wanted to half it again, I could do. It just gets a little bit extreme. Keep halving it if you don't need to. I would say that people could do the 8 times table. No problem at all. So divide it down at that point. Okay, but just to show you that you can, if I half 4, it's going to give me 2. Half of 149.6. 2's into 14 goes 7. 2's into 9 goes 4, remainder 1. 2's into 16 goes 8, so 74.8. And it's still even, so I could divide it down once more. Okay, 2's into 7 goes 3. 1 left over. 2's into 14 goes 7. And 2's into 8 goes 4. And you can see that there is my exact answer that I had there. So make it easier if you can't start it in relation to decimal division or larger number division. See if you can make it easier before you get going. Okay. So 21. Right. So key things in Venn diagrams, the little e doesn't mean anything other than everything that is in my particular question or in my set. Okay, it's what's called a universal set, and it just means all that's included is even numbers less than 19. So I'm going to write all the numbers out less than 19. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. The reason I put 0 is because we don't classify it as even or odd. So get rid of it. Get rid of the 1. Get rid of the 3, the 5, the 7, the 9, the 11, 13, 15, 17, 19. They are all odd numbers. Okay, not interested in them. So all I've got left is my even numbers. Okay, so get rid of that. Get rid of the 1. Get rid of the 3. Okay, and I know it takes a little bit of, it's taken a little bit of time to sort of like just draw these on to then just get rid of them, but it just want you to understand the process, if that makes sense. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18. Now set A includes 6, 12, and 18. So they're going to go in A. In this circle somewhere is going to be the red ones. Okay. In this circle somewhere, B is going to be 2, 6, 14, and 18. Now, if they're in both sets, they're going to have to go in the middle section. So we know 6 is going to go in there, and we know 18 is going to go in there. So we've used that one, and we've used that one. We know 12 is going to go into this section here. We know 2 is going to go into the section here, and 14 is going to go into the section here. So we've used 2, we've used 14, and we've used 12. Okay. Anything that we've got left has to go in the square around the outside. Doesn't matter where in the square, but anywhere. So we could say 4, 8, 10, and 16. 4, 8, 10, 16. And that's completed that question. Okay. Question 22. Give your answer as a mixed number. Okay, and we're going to do a calculation of fractions where we are subtracting. Remember, adding and subtracting fractions. Okay, this is recall of knowledge. I've got to have the same denominator. Same bottom number. I've got to have the same denominator. Right, so let's look at the minute. I've got 5 and I've got 3. Now, again, there are 2 ways I can do this. Okay, I'm going to show you the most effective way to try and stop any mistakes. I've got 4 and 1/5, so I'm going to make them improper fractions. So I'm going to do 4 times 5 gives me 20. I'm then going to add this additional 1 to the top, but still make it over 5. So 4 and 1/5 would be 21 over 5 as an improper fraction. Doing the next one, I've got 2 and 2/3. So I'm going to multiply those together. That's going to give me 6. Then I'm going to add the 2 over 3 still. So that's going to give me 8 over 3. So I've converted that into improper fractions. That gives me 1 mark. Okay. Still going to write the sum out again. 21 over 5 this time. Take away 8 over 3. Now the denominators are not the same. So it's at this point that I need to get the denominators the same. Okay, one way to get the denominators the same is to multiply these 2 values together. So 5 times 3 will give me a common denominator of 15. Because I've times the 3 by the 5, I have to times the 8 by the 5. Now, bearing in mind, I'm doing the second value, so it's got to go on the second fraction. So 5 times 8 gives me 40. Now I'm doing the other way around. I'm doing 3 times 21. I'm going to go on the first fraction. 3 times 21 is 63. Okay, and remember, we're taking this away. Because I've got the denominator the same, I'm going to end up with 15 as a denominator, and 40 away from 63 gives me 23. Remember, we want it as a mixed number. So I can get one whole lot of 15 out of there. And if I took one full box of 15, 23 take away 15 would give me 8 left over. So I've got 8 15ths, and that's my answer. 23. Okay. We're now getting into the higher worded questions that are quite in depth to work through. So again, the rule of thumb on this, the rule I would use is do it a line at a time. Try and make sense of what each line is telling you by listing it down, so it's a logical reasoning for the examiner. So at the end of 2017, Tamara's house was worth this. So 2017, Tamara's house was worth 22 at £220,000. Rahim's house was worth £160,000. Okay, so we've got that information down. Move on. At the end of 2019, Tamara's house had decreased by, gone down by 20%. Rahim's house had gone up by 30%. We've got that information down. Now the key question. At the end of 2019, whose house has a greater value? So my answer is going to be Rahim or Tamara. Okay. And why? So let's just look at Tamara. So we've got Tamara's house went from 220,000 and it's gone down by 20%. So £220,000 is 100%. 10% divided by 10 gives me 22,000. So 20% times by 2. Remember we divided that by 10 to get 10%. Times it by 2 gives me £44,000. Okay. And remember it's gone down, it's decreased. So my sum is 22,000. Take away the £44,000. 000. Borrow from there. 4 from 10 gives me 6. 4 from 21 gives me 17. So Tamara's equals £176,000. Okay. Rahim's. Okay. Started off at £160,000. It's gone up by 30%. Well, again, so the 10%, that's 100%. Divide by 10 gives me 10%. Times by 3 is going to give me 30%. So 10%, 16,000. This times by 3. Well, 3 times 16 is 48. Okay, and if you need to do a separate sum for that one, that's absolutely fine. Okay, so that's the value I want to use, £48,000. And remember, it's gone up, so I'm going to add it on. So £160,000 plus £48,000. 0, 0, 0, 8 and 0 is 8. 4 and 16 is 20. So £208,000. So if it wants to know who is Rahim's is the greatest value. And again, it says whose house has the greatest value. So it just needs a name. Okay. Here's all the workings that goes with it. And again, we'll logically set it out in a way that we can see 2017, 2019. The examiner can check through each of the working stages that we've done. And we've got the two values at the bottom here. So questions like this is quite important to try and maximize the 4 marks that's available in the question. Okay, question 24. Okay, this is one of the ones that a lot of people did struggle on when this paper first came out. Okay, so again, we're going to work through the question piece by piece. First line of the question, we've got Rosie, Matilda, and Ibrahim. So we've got Rosie, Matilda, Ibrahim. Collect stickers. Number of stickers Rosie has, number of stickers Matilda has, number of stickers Ibrahim has equals 4 to 7 to 15. So all we've done is we've taken the whole of that top piece of information and written it again, but put in an R, an M, and an I over the top of it. That's all we've done. Next, Ibrahim has 24 more stickers than Matilda. So whatever Matilda has, Ibrahim has 24 more. Okay. So here's Matilda's. Whatever Matilda has, he's got 24 more than. Ibrahim has more stickers than Rosie. How many more? Okay. Now, at the minute, we're thinking we don't want to make this algebraic. We don't want to make it really complicated. At the minute, what's the difference between Matilda and Ibrahim? Well, 15 take away 7. That difference is 8. We know that he's got 24 more tickets than Matilda. Think of the link between these two. 3 times 8 gives me 24. So let's multiply all of these by 3. 4 times 3 gives me 12. 3 times 7 gives me 21. And 3 times 15 gives me 45. Now, if we look between these two values, we can say that 45 take away 21 gives me 24. So Ibrahim does have 24 more stickers than Matilda. The question wants to know how many more stickers does he have than Rosie. So my sum is 45 take away 12, which is going to give me 33 more stickers. Okay, question 25. So the diagram shows a prism. What type of prism? It's a triangular prism. What do we know about triangles? Base times height divided by 2 is the area. To find the area of this bit. Okay. If I wanted to know the volume, I need to times it by the length. The area of the cross section multiplied by the length. That's the information that comes to mind. I haven't even looked at the question yet. So the cross section of the prism is a right angle triangle. The base of the triangle has length 5. The prism has a length of 25. And the volume is 750 centimeters cubed. We need to find the height. So it wants me to find whatever that size is. That side is. So work out the area of the triangle. The base is 5. Base times height divided by 2. That's what I'm going to write down. Base times whatever the height is, I don't know. Divide by 2 times by the length, they give me that as 25, equals the volume of 750 centimeters cubed. So at this point, we've got 1 mark because we've substituted what we know into the formula that we needed. Now I just need to simplify all of this side, so I've got h on its own. Okay. So let's try and simplify away. If I could get rid of the 2, divide by 2, okay, I'm going to. If I could get rid of the 25, dead easy in a minute. And then I need to get rid of that 5 because I want h on its own. So let's think what we can get rid of. So I'm just going to circle this and say, that's what I want on its own. I'm going to do this in different colours so we can see each stage. That's the next thing that's closest to h. That's the next thing that's closest to h. And then finally, okay, I've got this piece over here. I need to get rid of the 25. Okay. Now, one method I tend to use for this is I just talk about Shrek and how in Shrek's film they say that ogres are like onions, they have layers, and we're just going to peel off each layer to make this sum easier. So the outside layer is this one here, times by 25. So because it's times by 25, remember on everything algebraic, if we're trying to solve for a letter, we want to solve for h in this case, we're going to try and peel away the layer and do the inverse function. So we've got 750. If I can get rid of that one, I'll make life easier. I've got 5 times h divided by 2 equals, need to divide that by 25. So how many 25s go into 75? 25 goes into 75 3 times. 25 goes into 0 0 times. So I've done the first step of the equation. I now need to get rid of the 2. So let's get rid of the 2. Okay, so I'm dividing by 2, so if I want to get rid of that, I've got to times by 2. So 5 lots of H equals 30 times 2, which gives me 60. And the last step, remember 5 times H is the same as 5H, so I'm dividing by 5 this time. Get rid of that. So H is going to equal, how many 5s in 60? 12. So my answer is 12 centimeters. If I wanted to check, okay, 12 times 5 divided by 2 times by 25 equals what? 12 times 5 is 60, half it is 30, 30 times 25 gives me 750 centimeters cubed. So that's my check. I can put them back into the equation and see that they work. (26). Okay. Any questions at the end of the paper that you can maximize your marks on is an absolute bonus. Okay, so the diagram shows a cube with edges of length x centimeters and a sphere of radius 3 centimeters. It gives me a formula here. That's going to be important. I'm going to need that. The surface area of the cube. Okay, so surface area tells me it's a cube, so they're all the same measurements. Okay, all the sides are the same measurements. Is equal to the surface area of the sphere, and it gives me that measurement. So we need to show that this is my answer. I've got to get to that answer where k is an integer, and I need to know what the k is. So let's see what we've got on this. The surface area, we've got 1, 2, 3, 4, 5, 6 different sides. And to find the area of a cube, or the area of a square, we're just going to do this measurement here times by itself. So we know that's x centimeters. It's a cube, so it's a square, so they're the same measurements. So I've got x times x gives me x squared. And remember, I've got 6 faces, so I'm going to do x squared times by 6 gives me 6 lots of x squared. The 6 lots of x squared is going to be equal to my sphere measurement. Remember, it says the surface area of the cube is equal to the surface area of the sphere. So I can make that equal to 4 pi radius squared. Now, we're going to try and simplify, and we've got to simplify for x. Okay, so we've got to try and solve for x, just get to x on its own. Well, this side, how do I get x on its own? Again, thinking about my Shrek method. Here's my x. What's the first thing that happens to it? Well, thinking of BIDMAS, it squares first, and then after it squares, we times it by 6. So we're going to try and do that in reverse. Okay. So let's look at the information they give me in the question. They tell me that the radius is 3 centimeters. So let's solve the opposite side. 4 times pi times 3 squared. Okay, so 3 squared, 3 times 3 is 9. Do that bit. And then we can do 4 times 9 is going to give me 36 pi. So we've now got to a point where it's easier, because 6 lots of x squared equals 36 pi. It looks a simpler equation to now solve. Remember what we're going to do. We're going to do these backwards in order. So we're going to get rid of the 6. Remember that was 6 times x squared. So divide through by the 6. 6 goes into 36 6 times. Remember that's x squared. And to solve for the x squared, remember we're just going to need to square root both sides. So x equals the square root of 6 pi. So k equals 6. Okay, key thing on that one. Make sure you just substitute everything that they give you in the question. They told you 3 is the radius. Substitute it into that one. That's what we did here to get 36 pi. Remember to say what you know. If I can work out the area of the square, length times width, x squared. I've got 6 faces. That gives me the total surface area. I can then get to that point and start solving that question. All right. Think what you know about each question. It's going to maximise your marks. Question 27. Okay, last 2 questions. Freddie measured the length of a pencil to 7.2 centimetres, correct to 1 decimal place. Complete the error interval for the length p centimetres of the pencil. Well, if my number is 7.2, we're thinking the number that would round down to it and the number that would round up to it to make it effective. We've already rounded it. So if we did 7.2 something, what would that number be that would round up to it for a start? Okay, so a simple way of thinking about this is we're rounding it to that point there. So it's going to have to be below that. So 7.15. And we will always end in floats in relation to error intervals. Okay, so 7.15 would round up to 7.2. Think about up here, 7.249999999999999 would round down because we're rounding it to this point. Remember, just the 4. Okay, but remember I said that it always ends in 5. Okay, so to round up 7.15, to round down, it's got to be less than 7.25. So remember I said it ends in a 5 each time. Look at my sign here, it's got to be less than 7.25 and it's got to be equal to or bigger than 7.15. Always ends in 5 and we're rounding it to 1 decimal place, remember? Okay, so overall, we look at the difference between that, it is going to be 0.10, sorry, 0.1 difference. Okay, so 1 decimal place. Okay, if you're unsure about error intervals, let's just have a quick look at if it was, say it was 7.8, right? Remember, think about this in the sense of go exactly the same number and add a 5. Now the 1 decimal place, that reduce it by 1 and go underneath it, 7.75. And that will give you the same answer. Okay, so exactly the same number, add a 5 if it's a decimal one. Okay, and then 1 below 7.75. Okay, question 28. This is your last question. The equation of a straight line is y equals 3 minus 4x. Write down the gradient of L. Okay, so y equals 3 minus 4x. We are used to seeing it, or we like to see it, in this format. Y value, gradient, x value, y-intercept. We want to know the gradient, so it's whatever is the coefficient of the x. So the number that is with the x, that is your gradient, including the sign if the sign is with it. So that is minus 4 is your gradient. No other workings to do. Part 2, write down the coordinate where the y-axis is crossed by this line L. And again, if you've got the gradient already chosen, the other digit that you're looking for is the y-intercept. So my y-intercept, remember, here's my y, here's my x, okay? And it's going to cross at this point here, where y equals 3. But remember, at this point, x equals 0. So along the corridor is my x, which is 0. Up my stairs, which is y, it's going to give me 3. So while my y-intercept on my line is 3, my coordinate has to be 0, 3. Okay, I hope that was useful, and I'll catch you next time.